Okay. 5, 4, 3, 2, 1. So here is the review that's like on Teams. It says this is what you can do for review for your test. So first of all, you can do the review quiz to see where your strengths and weaknesses are. The answer will be posted by either Friday later in the day or Saturday, okay? Section for 2, there is the mega mole review. The mega mole review has questions organized by section, and there is a mixture at the end, and it covers sections 5.1 through 5.5. Empirical and molecular formula. Hebden has a bunch of good questions that kind of do, the more tricky ones where it's like, we've given you a percent composition, and then we've given you the density of a gas, and we're like, find the molecular formula. Yes? So that is where you can find some of those. So my suggestion to you is, I am unable to scan in Hebden. I'm still fighting I don't even call them pantry moths anymore. The effing pantry moths. I would say the word, but I'm not supposed to here. I'm still fighting them. My house is like torn apart. I cannot scan a document. I cannot scan it in. So if you want those questions, you are going to go and get one of those books and sign it out. Okay? They're like, you can just take it home and leave it there. Yes? Yes. Mainly calculations. Okay? Mainly calculations. And understanding of concepts. There will be some multiple choice, which does involve like sort of some mental math, but it requires you to understand concepts as well, okay? But the written part is almost all calculations. And then combustion analysis, which we are doing today, the big black book is now online, and the key is also online in our Teams. So are we good? Okay, cool. Let's learn combustion analysis then, shall we? That would be 5.7F on page 126. Page 126. Combustion analysis is a powerful technique for finding this. Yes. Yes. Combustion analysis is a powerful technique for determining the simplest empirical formula of a compound. Remember that the simplest formula is a lowest whole number ratio of elements that can represent the composition of a compound. Here is how combustion analysis works. We have a hydrocarbon made of, guess what? Hydrogen and carbon, and we burn it. What do you need in order to burn something? Oxygen. So it is burned in oxygen. There may be other nonmetals as well. So there's going to be hydrogen, there's going to be carbon, and there may be other nonmetals in that compound. Nitrogen, fluorine, whatever. All of the carbon gets converted into carbon dioxide, okay? So all the carbon gets converted to CO2. And then we measure the mass of the CO2. There's actually like, you burn it and it goes through like this pipe, and then there's a thing that collects the CO2. It like sucks it out. I forget how. We don't actually have one, so I don't know. And then all the hydrogen gets converted into water, H2O, because the products of combustion are CO2 and H2O, okay? And we measure, once again, we measure the mass of the water. There will be like something that collects the water as well. So now we have the mass of carbon dioxide. Could you find the mass of carbon? Yes? Are you saying yes because you think you should say yes, or are you saying yes because in your head you're like, I would do blah, 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 blah. Blah, 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 blah. We're good? No? Okay, it's all right. We will get there. Okay, so if you're not blah, blah, blahing yet, we will get there. If you are, then you're ahead of us. Okay, so here we go. We have our methane, for example, and you'll notice we've got our carbon has gone into carbon dioxide, yes, and we have the hydrogens have gone into the, what was that? Okay. Anywho, our hydrogens have gone into the water, right? We started with 4 hydrogens and we finished with 4 hydrogens. And at this point, we go back to our poem, yes? Find the mass of each element. And then we do mass to moles, divide by small, times to whole, la, la, la. The only new bit is how we find the mass of each element. There are several ways to do this. This, I think, is the fastest way. You could, if you wanted to, you could say, if I have grams of CO2, could I convert that to moles of CO2? Yes. Could I convert that to moles of carbon? You sounded unsure about that last one. Could you? If I had 3.8 moles of carbon dioxide, how many moles of carbon would I have? 3.8. Okay? So is that an issue, or are we good? Good. Okay. Now, what if we had H2O? So if I had my grams of H2O, I could convert that to moles of H2O. What could I convert that into? Moles of H. If I had 0.8 moles of H2O, how many moles of H would I have? 1.6, because I've got 2 of them for every one of them. Okay, so that is one way of doing it. It's not the way I've written here, but I don't know that the way I've written here is any less complicated. I'm like, this is the simplest way, and I'm like, well, that looks pretty simple to me as well. Okay, so that's perfectly good to do it that way. Yes? Oh, I know why I did it this way. It's because if we have another element, this sort of saves us a step if we do it this way. So here's the other way to go about it, is that we can use the mass ratio, which we haven't talked about so far, but does it make sense that within our compound, we have 12 grams of carbon for every 44 grams of CO2? You're not allowed to answer. You know everything already, okay? Because if you say yes, then I get a false positive, perhaps, yes? Okay. Does it make sense to say if I have 18 grams of water, which is the molar mass of water, I have 2 grams of hydrogen? Yes? So you can use that mass ratio to find the mass of each element. Yes? Okay. Once you got that, you could go from there and you could find the moles of carbon and the moles of hydrogen. And that's not too much different than what we did up there. They're both two-step processes, yes? So either way is good. Here's the only place where it might make a difference. If you have a third element, you are going to find it by taking the mass of the sample. This would be your hydrocarbon. This would be your compound. Right? We'll be like, oh, we gave you 5 grams of the compound and then we burned it. Yes? So we would take the mass of the compound, that 5 grams of the compound, and from that we would subtract the mass of carbon and the mass of hydrogen, which is why I kind of prefer this method, because now I've got grams of carbon and grams of hydrogen. So if I need to do that, I mean, I could do it the other way where I go to moles, but then I would have to take these then and go to grams and grams, right? It still works. It's just maybe a little more work, okay? Did I confuse you guys by that, or are we good? We're good? Okay. All right. So now here's the little thing that most people, if you're going to get something wrong, here's where they will go wrong. Sometimes people think, oh, if oxygen is the third element, I must be able to find the oxygen from the CO2 and the H2O, right? So if I had a compound that was CXHYOZ, they're like, oh, the oxygen must be the amount that was in the CO2 and in the H2O. But is that the case? Here I have wood alcohol. The oxygens are red. The 2 oxygens from the wood alcohol I've highlighted, yes? So they have like a little yellow halo on them. So now when I go over to my products, I don't even know which ones. The oxygen, it could be this one and this one. I really don't know which 2, but it is only 2 of them. All the other oxygens in the water and in the carbon dioxide comes from the air. Yes? So you can't say, oh, all of the oxygen in carbon dioxide came from the oxygen in the compound, because it didn't. Some of it came from the air. So you can't do it that way. You have to find the mass of oxygen by subtraction. You take the mass of the compound, you subtract the carbon and the hydrogen, and you end up with the mass of oxygen. So don't treat oxygen any different than any other element. Okay? Just don't do it. Okay, so you can't be like, oh, mass of oxygen equals grams of CO2 times 32 grams. You cannot do that. Okay, you cannot do that. No, just don't. Just don't. All right, shall we do this example? Isopropyl alcohol. If it's an alcohol, what group does it have on it? Do you remember? Alcohol has an OH group. which is known as a hydroxyl group. Do you need to know this for your test? Hydroxyl group? No, no, no. Okay, this is like organic chemistry, and it's not on the AP exam, so I'm not going to teach an official unit on organic chemistry, but I will keep throwing it in, okay, so that you'll see it along the way. It is a substance sold as rubbing alcohol. It is composed of carbon, hydrogen, and oxygen. Combustion of 0.255 grams of isopropyl alcohol. So our isopropyl alcohol is going to be C something, H something, O something, and we just don't know what yet. How much of it are we burning? All of it. That's a good question. Oh, it's buzzing. It's telling me I should be more active. Well, not right now. Okay. Maybe that was what was buzzing before. My watch. I don't know. Anyway. How much of that stuff do we have? Read your question. What? 0.255 grams. That's how much we have. 0.255 grams. Okay. And we know that we also have a certain amount of CO2 and a certain amount of H2O. So we're finding the mass of each element. So I am going to start with my carbon dioxide. Sorry, grams of carbon. I'm going to start with 0.561 grams of CO2. And I want to convert that into grams of carbon. So what do I need to cancel? Grams of CO2. And I need to find grams of carbon. Yes? And like I said, you could do this by using moles, but you can just do this directly grams to grams. So what is the ratio there? So if we have our, you could get, if you, like on the side, you can be like carbon, I have 12 grams. Oxygen, I have 32 grams because I've got 2 of them, right? And so that gives me 44 grams, yes? So there are 12 grams of carbon for every 44 grams of CO2. And we get 0.153 grams of carbon. Okay? We're going to do the same thing. Oh, did I do it wrong? What? Why? What did you get? All good. Okay, cool. Now we're going to find our grams of hydrogen. Grams of hydrogen, what are we going to start with? We're going to start with our H2O, 0.306 grams. Whoops, H2O. I wrote CO2, silly me. And again, if you happen to know the molar, do you happen to know the molar mass of water? What is it? 18. If not, you can write that over on the side somewhere, okay? So we want to cancel grams of water and find grams of, are we finding grams of H2 or grams of H? Just H, okay? Grams of H. So we have 2 and 18, and we get 0.306 times 2 divided by 18 is 0.034 grams of hydrogen. So now, yes. It would not be good for you. It would not go well. It is not a fun alcohol, okay? Even the fun alcohol causes cancer, so be careful, right? Wood alcohol, methanol, will cause you to go blind. I don't actually know what isopropyl alcohol will do, but it will not be good. Methanol depends on how much, but yes, it can make you go blind. Yeah. I don't know. It's a good question, though. And if we weren't trying to finish off this unit, I would look it up right now, but we're going to finish this off first, and then maybe we'll look it up. Okay. So, my friends, here we are. We have grams of carbon. We have grams of hydrogen. What comes next? Mass of oxygen. By subtraction, what are we putting at the front of our, hi, yes, yes. Because there are 2 hydrogens, so proportionally within that 18 grams, 2 of the grams are hydrogen and 16 of the grams are oxygen. Does that make sense? Yeah, cool. Okay, so we have 2 grams of hydrogen in 18 grams of oxygen. What are we going to start with here? What's the thing we're going to be subtracting from? You don't need to write, you don't need to look it up, you need to think about it. Think what makes sense. What is the bigger number that I'm going to be taking things away from? The one that is, what am I taking away? What am I taking away things away from, and what am I taking away? I'm taking away the hydrogen and the carbon from the isopropyl alcohol. So I'm going to start with my isopropyl alcohol. And I'm going to subtract 0.153 grams of carbon. Do you guys like doing subtract, or do you like doing subtract bracket plus? What do you like? Bracket plus, okay. Plus the hydrogen, which is 0.034 grams of hydrogen. So I'm subtracting all of that from the mass of the isopropyl alcohol, and we get, huh? You're more of a subtract guy. I'm kind of more of a subtract person, but it's because it involves less keystrokes on the calculator, yeah. But the visualization is also important. I can see the effectiveness of that as well. So here we have now 0.068 grams of oxygen. At this point, is this question any different than anything you've done before? You now have mass of each element. What will you do next? Mass to moles. Okay, off we go. So I want my moles of carbon, 0.153 grams of carbon. I want my moles of hydrogen, 0.034 0.34 grams of hydrogen. And I want my moles of oxygen, 0.068 grams of oxygen. And I like to treat these like a little assembly line where I sort of just do everything. I'm like, okay, cancel grams of carbon, cancel grams of hydrogen, cancel grams of oxygen, find moles of carbon, find moles of hydrogen, find moles of oxygen. Molar mass of carbon is 12. Hydrogen is it 1 or is it 2? 1. Excellent. And then we have the oxygen, which is 16. And then we have 1, 1, 1, equals, equals, equals. And then we go to our calculator and chuck away. Divided by 12. 0.01275 moles carbon. 0.034 moles hydrogen. And 0.068 divided by 16 is it gave me 4.25 times 10 to the minus 3, but I'm going to write it in non-scientific notation because it'll look more like the other numbers. So 0.00425. It makes it easier for me to see that that is my smallest number. So now we are going to divide by our smallest number. So here's my carbon. Have I done this right? That number looks a little weird to me, but we'll see. I'll keep going and hope for the best. The oxygen is wrong? Okay, hang on. 0.068 divided by 6. Huh? Oh, the 0.068 is wrong. Okay, hang on. 0.255 minus 0.153 minus 0.034 equals, huh? It's all in brackets, so you minus this and you minus that. So these go together, and then you subtract it. Yeah. So 0.255 minus 0.153 minus 0.034. Yes? Because here's methanol, which is a similar compound. Here's the oxygen from the methanol. And then there's some oxygen from the air. I don't know how many of these came from the compound and how many came from the air. Why? We need to find the amount that was in the compound. So I'm trying to figure out that there were 2 oxygens coming from this methanol here, right? So I'm not concerned about how many came from the air. That's just like extra stuff. Plus you have to do more calculations, which is just a practical reason for doing it. But the real reason is that you will get an answer that has way more oxygen than is actually in the compound, because you would be including all the oxygen that came from the air. Yeah? Yeah. Yes. Is it just 3? That would make so much more sense. Yes, that was why I was like, I don't know that, there we go. Is that good? Okay, phew, I was thinking it was looking a little weird. So there's our carbon. Now we have our hydrogen. 0.034 divided by 0.00425. 8. And then O, very straightforward because it's just 0.00425 divided by 0.00425. And that gives me 1. So our empirical formula then would be C3H8O. Is good? You look puzzled, Itamar. You're just squinting at the screen? Okay, yeah. So that's it. So other than that little bit about finding the mass of the carbon from the CO2 and finding the mass of the hydrogen from the H2O and then finding the mass of any other element by subtraction, it's all the same. Yes? Because we're finding the empirical formula, it doesn't matter. You can just give it as the most simplest way possible. If you wanted to write it as C3H7OH, you could, and it would not be wrong. Yes? But this is simple enough. How do you draw that? That's a really good question. Okay, so we have C3. Carbon always forms how many bonds? Or almost always? 4. So I'm going to put all my carbons together. Okay? Because they form the most bonds, so they'll be sort of central. Carbon always forms a chain, and then other things come off of it. All right, and then we have H8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, good. Look, everybody, all the carbons have 4 bonds. And then I'm going to put hydrogens on the ends of each of those bonds. I have a choice as to where I put my OH group as opposed to just a plain old H. Okay, but I'm putting it in the middle because this is called isopropyl alcohol. Iso means the same. Right? If you have an isosceles triangle, these two angles are the same. And so you can see this is a symmetrical version of this alcohol where you have the left looks the same as the right. Whereas if you were to put the hydroxyl group on a terminal carbon, one of the end carbons, it's different from left to right, yes? So this is why the name of this is actually, the technical name is actually 2-propanol or propan 2-all. I don't know which is the most up to date. Last time I took organic chemistry was 30 years ago. Okay, yes. I mean, honestly, this thing actually bends like this, where you've got a carbon and a carbon and a carbon, and these things spin on their axis. What we do is we say, we're making, the reason they call it iso, I don't know. They have, I mean, it's just based on its Lewis structure. And its Lewis structure is how it is. Yeah? Yeah, it's not based on its realistic structure because the realistic structure is 3-dimensional. And each of those carbons, oh, let's go back to this. Each of those carbons has 4 things sticking off of it. What arrangement do those 4 things sticking off of it make? There's 4 bonds which contain electrons, and remember, electrons all repel one another. It's like a little tripod, yes? Yes, each carbon has a tripod, but we don't call it a tripod. We call it a tetrahedron. So what's actually going to happen is that you're going to have a carbon with this tetrahedral structure bonded to another carbon that has a tetrahedral structure. It's really hard to draw tetrahedrons in 2 dimensions. Okay, that looks nothing like a tetrahedron. Okay, but you end up with something that looks like that. And because these bonds can spin, it will actually go like this, and then it'll be like this, but it's not a nice straight line. We'll get out some molecular models at some point so you can actually build it. Yes? No. No. Maybe, I mean, you should, over the summer, I think you learned what an alcohol was. But other than that, not really. Okay? Yes? This will not be on the AP exam. Okay? Organic chemistry is not on the AP exam. But if you go into any sort of biology or biochemistry, or even if you're just taking first year chemistry, chances are you're going to run across some organic chemistry. Okay? You do not need to take it if you get a 4 or a 5 on the exam. It depends. Some schools will only accept a 5. If you go to McGill, they will require you to take the credit. They are the only school that I know that does that. Everyone else will let you choose. Okay? I actually had a couple students, they were like, I want to take the course, and then they went to McGill, and they're like, nope, you're in second year, off you go, bye. And they were a little stunned by that. However, they did survive. I was talking to, it was your mother. I was talking about your brother, who was my student 10 years ago or so. And yeah, and apparently he had that experience. I think it was him. He went to McGill? Yeah. And he got stuffed into second year chemistry, and then off you go. And it was a little bit terrifying at the time, but he survived. He's doing his PhD now. So, you know, we all survive whatever horrible, stressful things that first year university throws our way. So when you are feeling like, oh my God, the world is out to get me, it is crushing me, you will be okay. You will be okay. And you can always find me on Facebook, and you'll be like, Miss Spence, I'm not going to be okay. And I'll be like, no, honey, you're going to be okay. All right? Yeah. Okay. So, this would be named 1-propanol. Or propan 1-ol. And you might be like, why is it not 3-propanol? Because it looks like it's on the 3rd carbon, yes? However, if you were to take that structure and flip it, it would be carbon number 1. So it's actually, this is the same as that. They're the same molecule, just rotated. Yes. So if we drew it like this is the same structure as the one above. Yes, these two are the same. They're identical. Is propan-2-ol the same? No, because it's got it on the central carbon. Yes? So that is different. So there are 2, and these are what we call structures that have the same molecular formula, but different structural formulas are called isomers. Isomers. Okay? One propanol and two propanol are isomers of each other. They have the same molecular formula, but different structural formulas. And actually, when you take organic chemistry, they usually let you have a molecular model kit with you. So you can build things and see how they rotate, like even on exams and stuff, right? Because that whole picturing things in 3 dimensions or trying to draw it in 2 dimensions is just really difficult. So they usually allow you to have your own molecular model kit that you can muck about with. Alrighty. Do you want just some time to try some of these? Yes? And you know what you're studying for the weekend? And you have one of those if you want it or not, you're going to go get one? Okay, excellent. Are we moving on to Unit 2 on Monday? Yes, we are. Oh my God. There are answers there to that. It's easier just to sign out the damn book. Like, honest to God, just take the book home and leave it there. Then you have it to study for, like, whatever other units come up as well, right? I should have just made you all sign it out at the beginning of the year. That would have been more sensible.
Yeah, his name's Angie. Oh. What?
Yes, if you are on your lap today, you can hand it in.
We'd be able to keep this at home and have it.
Keep that at home. Don't bring it back and forth. Just take it home. If you need it at school, I've got a class set here. Okay, so have them just take it home and leave it at home.
Alvin.
We don't learn from here, but there's lots of good reviews.
Alvin.
You can keep it at home. Yeah, and then you're not. Thank you. You need a book card?
Yeah, I need a book.
Yes.
You know how to make my calculator un-German? Just like really quickly, like some of this is also in German.
Oh. Oh, so you have a German calculator.
Yeah.
Why don't you get yourself a non-German calculator?
Because like I don't know, because most times in English, because like for example, if I just press like this, it's all in English, right?
Okay.
And then if I just press table and I plug in a number, then it just becomes German.
Okay, you know that this style of calculator is like $10, right? Yeah, I don't know if there's a way to get it out of German mode if it's a German calculator.
Yeah, I'll get it.
Or the empirical formula was determined to be. Thank you. Thank you. Just right there. Thank you. Thank you. Thank you. Thank you kindly. Did you guys want to see a demonstration? Just a really quick one. This is just left over from my regular chemistry lab. I'm not going to drink this because it's not actually water, but I'm going to prove to you that it's not actually water. Does it look like water, mostly? Okay. It is not water because, and I'm going to put this black behind it so you can see.
Why is that not water? Oh, it's turning blurry. It's not what the guys being exposed to water. It must be water. No, it's being exposed to carbon dioxide.
So we now have a heterogeneous mixture here, whereas before we had a homogeneous mixture. What we had in there was we had some calcium ions. We had calcium hydroxide that my other class had made. And I bubbled into it some carbon dioxide, which turned into carbonate ions in the water via a more complicated process than that. And carbonate is very low solubility with calcium. And so now we have calcium carbonate, solid little particles forming in there, and that's what's scattering the light back at you. And that's why it looks cloudy now. And I poured some of it, and if that wasn't enough to prove that it wasn't water, I poured some in this flask earlier, and it turned pink because there was phenolphthalein in there, and phenolphthalein turns pink in the presence of hydroxide. So always good to know that whatever you have in the chemistry lab, you cannot assume it is water. So if you find a puddle of water on your desk, don't assume it is water. Okay? Make sure you use care when wiping it up and wash your hands afterwards. We kind of do. I think we might actually have some right now. Ms. Wu and I usually just fake it because we've got very soft water here. So we just make tap water and pretend it's close enough for most high school purposes. Yeah, I think we actually do because we had a lab tech come in the summer and make up some solutions and stuff like that. Yeah, so it's very nice.
Do the hot dog.
Yes, thank you.
No, we did.
I don't know what I've done with the little tray. Oh, here it is. There we go.
Hope you get a good grade.
Just laugh at all my jokes. Remember, laugh at all my jokes. Yes.
You're talking about
One question.
They are long. That means when you're test, I can't give you more than one of them because otherwise that would be the entire test. You know what I mean?
half an hour for questions.
Yes. Like I could not give you more than one of those. That would be ridiculous. It's legal size 1, 2, 3, 4. Or is it 6? You guys can stay after school and finish. Does anyone need to leave early on Tuesday? I'm just saying because if you want to stay afterwards and have a little more time to finish writing your test, you can. Okay? So try and make sure that you don't have any like other commitments or whatever. On the other hand, I will not be staying until 4 o'clock to supervise you writing a test that was supposed to take an hour and 15 minutes, right? So.
What is our
Your homework for the weekend is to review for your test. And on Monday, there will be no official review time because your review time was on the weekend, but that's your chance to figure out if there's anything you don't know and to ask questions on Monday. If I spend all day Monday answering questions, that's fine. If not, we'll move on to our next student. Okay? You get a new one. I don't even know what color it is this time. It's a different color. Yeah.
Let's wait for this. Blue.
I say green. I think purple.
I've had people bet on these before. Yeah, this is like
Okay, well, this is unit 2. Oh no, so unit 5 is this, so that means green was unit 4, right? So that means unit 6 will be different.
yeah.
So you've already
Wait, what? How is unit? How do you know?
Okay, yeah. Unit 1 is unit 2 is big. So unit 5 is because you see
No, how do you know? No.
Wait.
Oh, you actually read it? I just read it. How do you know what the numbers are?
On my grade lines, I would do that. Like every time I'm like, okay, I bold everywhere. You have a highlighter, and actually it's good with doing that. If you go through and you're like, I have a 7-gram sample, I have 10.7 grams of CO2, 4.2, and that's the first thing you highlight that so that you can know.
I meant just over time.
Yeah. No, you don't. You just be like, oh, no. And you know what? You can do the same for all the other questions. And you do want to get good at the information from questions because on the AP exam there is no. So being able to be like blah 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 number, blah 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 number. Yeah.
Yo.
There is a way of having more elements and that's but I would have to do like this many grams of this other compound.
Is it 2021 or 2022?
2022.
Yo, you got me messed up, bro. Why did you say? Most of the time it doesn't matter. If it matters, I put no.
Thank you.